We are standing in one of my least favorite parts of my property, my yard. And the best way for me to describe what's happening here, I think, is to go back into the 1930s to a physicist who proposed a thought experiment called Schrodinger's cat. And the idea is that when something can't be monitored or when something can't be observed, it can be in all of its possible states. So in his example, a cat in a sealed box with a random explosion, I think it was a nuclear timer of some kind, that cat is either dead and alive until someone opens the box and finds out if it's actually dead or alive. This is, in my opinion, pretty much the same thing. There's a sump pump about 5 feet below this lid. Kind of hard to see the lid. Sand around here blows a lot. And either that sump pump is working just fine, or that sump pump has failed and wastewater that would normally come this direction to the appropriate septic tank area and leach field is being diverted north of here, or I guess that's south of here, to a smaller septic tank that's meant for just the bathroom in my shop. So there's no immediate notification if this guy stops working by some kind of backup. Sewage will still flow away, but it's inappropriate for it to go the south direction. It should be coming to this sump pump, and then this sump pump brings that wastewater up and then into the septic tank. It's using a very, very early device that I made, probably one of the first devices I made, that was flashed with Arduino IDE, and I happen to know it struggles to maintain Wi-Fi and then access to the MQTT server. And because of that, and because it was poorly written, it gets caught in a update loop, not the run loop. And so rather than operating normally, especially if we lose power and Wi-Fi, this device can sometimes not come back online well. In fact, it comes back online very poorly. And so because there's no flood and because I have no insight into the state of the chip, it doesn't send status because it's too early. It was my first designs. I have no idea if this sump pump has failed and if the water level has risen above the lid or if it's running perfectly fine. We're going to open the lid, and by opening the lid, we are going to immediately observe whether or not this thing's been running the whole time or whether it's been failing the whole time. So stick around. Guaranteed I'm replacing the chip with a better version, one that works without the chip. That's important. This one has to have the chip running. And then one that uses ESP Home for the code. And it is much better than what I did with Arduino IDE. So let me grab a shovel. We'll clean this area up a little bit, expose the lid, and then together we'll take off this lid and see if Schrodinger's sump has been running or if it's been failing this whole time. So stick around. This video is going to have a lot of fun stuff, I hope. Soldering, some code, introduction to home automation, and an example of how noisy you can make a device on your home automation system. So stick around. I haven't opened this box in a year or two, maybe more. In fact, I haven't even really been concerned about what's going on out here for over a year. So it's been a long time in this current state. All right, so see, I do try. There's a picture that shows the different ports in use on the ESP device, and you know, it's kind of nice. So I do have some lights going on, but I don't know what they mean. So there's a little blue light and a red light. This is the relay that turns on the pump. Pump's connected to an outlet that I put on the outside of this. It's good to see that the box looks dry. Sensors are coming in through here. So that's the original float that came with the sump pump. And then these are some extra floats that I put in place. But I have no idea if this thing works. So I have a new design, and that's what we're gonna roll out in this video, is the new design. Regardless if this works or not, I'm replacing it because we need more observing going on out here. All right, let's do the big reveal. We see a lid. Oh my gosh, do you realize what that means? Oh, there's cockroaches. That means everything's already working. That sump pump down in there is totally working just fine. Ooh, it still stinks though. There's a lot of dirt. Oh, I'm so relieved. I was expecting us to find 3 feet or 2 feet of standing water on top of that lid. We haven't found that. So guess what we're not going to do? We're not going to replace it. That's awesome. Well, oh, thank goodness. That means that this little chip in here, even though there's no monitoring on it, it's been doing its job for over a year, just quietly out here running like a monster. So let me explain why I'm doing anything at all. I have two kind of problems. Number one is the visibility into this process out here. I think I've already said that numerous times. But also the power that goes out to all these little floats, that power is explicitly being fed by the ESP device. So if I unplug this ESP device, or it dies, nothing on this chip can make the decision to send power to the sump pump. So we need to fix that. That sump pump needs to be running with a chip that does everything on its own, and the ESP device is like icing on the cake. So now that we know we're actually dealing with a running system out here, we do not have to open the lid and get down 6 feet underground fixing stuff. Oh, I'm so thankful for that. Let's just get right into building the new system, and then let's install it. In my enthusiasm, I was sure that everything was fine because there wasn't standing water, but this little part right here, this little black button, when I press that, I'm supposed to hear the sump pump come on. I'm not hearing the sump pump come on. It's dead. So thank goodness the lid is dry. We don't have to pump out that water, but that sump pump down there has either rusted for not being used, or it's clogged with stuff that's not supposed to be down in there. So dang it, we're going deep. Okay, old version gone. Sadly and regrettably. And the worst part about this is that the next step is to remove the old sump pump. And the fact that there's dirt down there and I can see like icky stuff on that surface there, it means that I'm going to have to clean out just enough to get to the bolts. And that's not going to be fun at all. So I don't like to use profanity, but crap, this is gonna suck. And that's not just dirt. I can tell water's been on top of this. It's dirt and water, and the water is always icky. All right, this is what I've got. Piece of metal conduit attached to my hose, my vacuum hose. So let's clean off some bolt heads. All right, the next thing we need is a really long socket extension. So I will start with a nice long one that actually does have a lock on the end. And that's where we'll put our socket. Start with 14 millimeters. I don't exactly know what size it's supposed to be. Then we'll put in another one and put a little tape around it. The work's happening up here. All right. See that? A little bit of electrical tape, and all of a sudden this guy's gonna be nice and long. Oh, and then here comes the sun. So if you thought this was uncomfortable before, it's gonna be 100 degrees plus today. Okay, here goes. Let's try our first one straight below us. Easy peasy. Let's reveal what's underneath this disgusting thing. I think this rope is here for a reason, so that we could lift the lid. We're going to try to lift, or sorry, there's a pump access at the bottom there. We're going to see if we can lift the entire lid off. Yeah. And yes, it's a tad heavy. I don't know if I want to do this without the help of a pick thing, because yeah, it's going to be, oh, it's doable. Oh, crap. Come on. Come on. Oh, that is the worst smell. Oh, that is disgusting. Okay, and as expected, we are left with a pit of absolute disgustingness. Oh, and we lost two of our screws. Oh, I hope we didn't lose any more than that. So 1, 2, 3, 4. I see 5 and 6 are down on the edges. I hope we didn't lose any down inside. All right. If they don't find you handsome, they can at least find you stinky and gross and doing projects that you have absolutely no business doing. This is gross.
Okay, we're a little off center, so we'll want to move the tripod eventually. We expected that that would get tight. Oh, yuck. Okay, that's as deep as I want the pump to go. Don't want it to fall on its side. And do you guys want to see the most disgusting thing? Sure you do. You may as well be right up center stage for this. The only precaution that I'm worried about is what if I drop my phone down into this abyss of disgustingness? Okay, with a little bit of sunlight there, you can see what I'm working with. Let's get this flushed out of there. Okay, the goal is for that that line to fill up but not jump too far. Okay, good. Not too bad. I don't think it should be taking so long. I wonder if it's because we're all kinked up. Again, what we're hoping to see is water flowing in, and I'm still not seeing any water flowing in. So we have a problem. Darn it. Okay, what's our status? The current status is the line between the house and that sump pump is blocked. And I can call somebody to come out and clear it. I could even do that after we've put everything together over there. But I watch the Instagram. I see the ads. And not too long ago, somebody was selling these pipe jet clean out tools. I've never used it, but this seems like a decent time to use it. So I'm in my shop now. And I need to find that little straight from China sump, not sump, line clean out tool thingamabobber. And you've seen me do this before, so I'm going to put it in high speed because I think it's kind of comical how poorly I keep my shop organized. Maybe you guys will see it as comedy too. Probably not. You probably think I should probably do a better job. I agree, but I haven't done that yet. So we're going to spend a few minutes looking for my tool. Enjoy. right, I give up. It's not easy to find in my shop. So there's a little shelf system in my garage. Maybe that's where I put it, because I thought maybe I would be using it on the inside. So let's go look there. You know, we're not completely without tools. I think this thing's 50 feet long. That might be enough to get us out of our bind. Let's go try this thing. All right, I've got water trickling in through the hose there. Should be just kind of drizzling. Yeah, not a ton. And let's unleash this thing. Okay, it occurs to me that I have not yet explained every component of this process, and so I think now would be a good time for me to do that. This is the lid of the sump that is below. Okay, that's easy. Don't think we need to spend any time on that. The primary method, let me just grab this one accessory. Primary method of this pump being activated is just going to be the float that comes with the pump. For hopefully years, when properly adjusted, this guy will just boom, turn on, turn off. Obviously, it needs to come up a little bit, turn on, turn off. And the only thing my little software chip will do is just observe. Its job is not to get in the way. It's just going to observe. There we go, that's better. So, you know, hopefully this float will outlast the life of the pump here, but I doubt that. I got a feeling, and we'll take apart the old one and look at it. I had a feeling that eventually these wires, this especially right here, is going to wear out. And that's not uncommon, right? That can happen. So far, the software I've written, all it's doing is observing. It hasn't done anything yet. Enter the lid to the float. Let's see. Let me lift it up just a little bit so you can see it. When it's installed, it comes with a low and a high float. The goal here is for this sump pump to continue to working even if one of these pops up a little bit. The problem is this is temporary. It would go on and then off, on and then off, on and then off. So this one requires the software that I'm writing to turn the pump on for, let's say, 20 seconds, and then it just turns itself off. That is another normal condition for this to be running in. I actually wouldn't care at all if this pump ran on this for another 2 years. That'd be great. However, if it ever trips this one, it's game over. Get out here, fix it, find out what's wrong. And I've done the same thing in my basement sump pump. So this just kind of plops in right there, and it's just business as usual. Float turns the thing on and off, and then little floats can optionally turn it on and off. And then, you know, the last thing my software has is the ability for me to turn it on from the house. If I just decide I want it to come on and off, I can do that. So I'm going to finish installing this. Again, it's kind of too hot for my phone to be out here and record. And there's nothing interesting. I'm just going to lower this in with my my strap, and then put the screws in the lid. It's not exciting. So finish doing that, and then that's kind of the last thing. Obviously, we'll do some tests with it done, but I might still ask a Roto-Rooter to come clean that line out, but it flowed great, if that's flowed's a word. So, okay, let me install this thing. This is where we'll be doing our work for this little project. And what I'd like to highlight is two things. Number one, no surprise, this little workstation is a complete disaster of project nonsense. Yeah, that's just who I am. But I've been working on this problem for a long time. I've had this problem. I've also got numerous attempts at the wiring of it, and I got some things wrong, and since I had hard soldered the little integrated circuits onto the board, I had to abandon these as well. So some components are forever lost, and that's sad. The goal is this right here. This is a working version that does pretty much everything I want, and it's documented here on this picture that's underneath everything. Yeah, I had to cut a piece out because I decided to turn it around, since the terminals that were interesting to the rest were originally drawn on this side. So I turned that around. It's nice that I can just cut it out. I'll have to tape all that back together. I will keep these in some documents in a file cabinet, just so that I can refer back to them to see what I was thinking and when I did stuff. But basically, the problem with the current solution is that it depends way too much on, where did it go? On these little chips. It depends on them being connected to Wi-Fi and connected to my home. It's called MQTT. It's a little messaging protocol thing. I'll try to show some later. But if the Wi-Fi at my home goes out, or if the power goes out and this comes online before the Wi-Fi, because it was hand-coded in Arduino IDE, it doesn't handle that situation very well. I found a much better replacement. All of my chips since I found ESP Home are using ESP Home, and it does a great job of rebooting the machine if it can't find Wi-Fi. But I had to design this differently. The design needed to remove this ESP device from the thing that actually turns on the pump. This is the relay pump here. So that's what these are for. One of these inverts a signal, the other one does a great big OR, and it has a whole bunch of inputs. And I'll get into some details in a minute, but basically this circuit should run as expected even if I remove the ESP device. And the version that's currently running doesn't do that. So here's the lowdown. Here is one input. This input is currently just a little momentary button, but this will be the float that's in the water with the pump. And when it's face down, it's not turned on, but as soon as it gets to a certain point, it kicks on, and we want the relay to turn on. Good. As it's draining, it goes down, it goes down, it goes down, it goes down, and then it gets to the bottom, it opens. We want the relay to turn off. Perfect. So this will be the primary thing that runs it pretty much all of the time. I then have a manual button that I'll put with the device. So the little enclosure, which is this box right here, somewhere on there I'll have a button that I can use to cycle the pump myself. So boom, you can hear the relay kick on, relay kicks off. So that's easy. That's something that I'm gonna do. On the lid to the sump pump, I will have two of these floats. One of them is actually installed a little bit higher than the other because the little pipe on one of them is longer. And these will also turn on the pump, but they will also ping my phone. And they make my Echo devices in the house scream and say something unexpected is happening. That's going to be good, especially if I'm home. If for some reason the network is down, one of those floats also causes this little device here to scream. And it's not super loud because we're using 3 volts as our voltage for the whole circuit. But if you're walking past it and you hear this sound, you'll know that, the network may have failed, but there's a problem out on the pump. So let me clean up this workspace, and we'll get started turning a blank chip
into one that has the components on it. So this one you can see I've already started before I started videoing. And the ultimate goal is this device here. So you'll watch me see how I solder, and then we've got some installation to do, and the installation won't be fun. Because I know for a fact the pump that's outside has failed. I know that because when I unplug it from my little robot device and plug it straight into power, it blows the circuit. So either it hasn't run in a long time, and there's a reason that it's allowed to do that and we don't have a backup. I'll explain that too. Or it ran for too long and it heated up and it broke itself. So yeah, we've got to get I think this is version 3 of this design deployed, working, and integrated with the home so that I no longer have to worry at all about these sump pumps. So that's what we're gonna do today. Let's take a little bit closer look at what's on this board here, and I'll try to describe these extra floats that I purchased and why I have to wire them the way that I did. I didn't realize when I bought these that the magnetic part that's here, that floats, the switch is inside, but the magnet's in here. I didn't realize that you can turn this float upside down and achieve a different kind of switch. Right now, these are normally closed, or NC, and it's perfect for filling things up. In fact, I have one of these on my above ground pool, and whenever I want to put water in the pool, I charge a sprinkler valve and then use this switch to turn it off when it's done filling. So it's normally closed means that this is turned on, basically like a light switch. And what I needed was the opposite. I wish that I had realized that if you turn these over, they're normally open, which means they're off, and when they rise, they turn on. Because of that feature, because I left them the way they were, because I didn't know any better, I needed this right here. And what this does is it takes whatever logic input is coming into this circuit and it flips it over. So if a positive voltage is coming into number 5, a negative will come out of number 6, or a logic off. And so that's why you see the orange and the gray wires coming into these, is that I needed them to be the opposite of what they are. And in order to achieve that, I do have to power this chip. So you'll see that there's a voltage and a ground on the other side over here. And then Claude recommended that I ground all of the inputs to 0 so that there's no flipping state going on inside this chip. So once I have reversed the logic of each of these, they then are free to leave that circuit. They are observed by the ESP82, 8266 or 86, I forget, anyway. They are observed by these two GPIO pins, but they make their way into the next circuit, which is an OR gate. And what this basically means is that the logic value of either of these being on will result in the output being on. And so I brought gray and orange into that gate, and I'm using orange again because I don't have infinite amount of wire to leave that gate. And what it really does is I've got 4 inputs on this side of the chip. As you can see, there is the manual override and the float pump. This is the one that's most likely going to be hit or running, and it's in this purple and this kind of dark green. And they both are also observed by other GPIO ports on the ESP device, but they find their way up to these 2 inputs of the OR gate. And so the output here is green and the output here is orange. And these 2 travel around and are inputs to more OR gates over here. And eventually they all come
out number 11. So I could have done like, I think it's a 1, 2, 3, 4, 5, or 6 import OR gate, but this chip was easy and I might want to use this for other stuff. But basically coming out of all of this is this blue line out of line 11, and that blue line just goes straight to the relay. And so I have a relay that can take 3 volts in as its input, and it will switch up to 40 amps, which is way overkill for our purpose. But anyway, there's some other interesting things. Because I'm working in logic, and the absence of voltage is not necessarily a 1 or a 0, all of my inputs that use the digital circuits are pulled down to ground by a 10K resistor. And so what that looks like on the chip itself is that, let's see if I can zoom in and still focus. You see how there's this blue is the output. So this red line here is input to this right here, and then it goes out to the float, and it comes in on either this one or that one. And as it comes in, it has this resistor that's also tied to this black wire underneath. So you can kind of see down there, there's a solder joint. Those connect underneath. And what that does is that when I'm passing 3 volts and this switch is closed, we're going to get 3 volts here. This is going to sap just a tiny bit of it away, not enough to mean anything. And then that blue wire goes into my NOT gate. Well, when I open this switch, rather than it just kind of hanging there, it's pulled to the ground through this resistor. So I get a very solid off signal. And so you'll see that that is common on a whole bunch of these inputs. I've pulled them to ground so that they don't interfere. In fact, all of the inputs are that way. I had to kind of change my plan. So this is the output to the relay instead of it being over here, which it was on the drawing. And that was just for convenience. These little 2-port ones ended up taking a little bit more room on the switch or on the circuit board than my drawing. And so it was just convenient to put 4 of them next to each other. But that's the, what do you call it? The logic part of this circuit. The rest of the circuit is really not that interesting, other than I have observation going on from all of these. And then D7 is an additional output. It's an additional signal that finds its way into, oh, I'm sorry, that's the pump float observation. Where's the one that comes out and goes straight to the, one of these jumps over everything, and just so that I can run this thing just from the ESP. 1, 2, 3, 4. Oh, it's this one. Sorry, they're kind of the same color. D7. I was right. It jumps over and then it goes, skirts by all of those, and it's an input to this guy right here. So that's the design of the logic circuit. I'd like to demonstrate what I've observed if you don't properly ground stuff. And so what I'm going to do is I'm going to show you what happens when something isn't properly grounded. And in order to do that, I'm going to remove the ESP from the circuit. And what that's going to do is that's going to let D7 float. There'll be no tie to ground, and there will be no hot. So give me 1 second to set the camera aside. Okay, now that my hands are free, I'd like to demonstrate 2 things. Number 1, the rules. The purpose for this is more important when you get into these floats, because the idea is that this float will be on the lid of the sump pump, and when it finally gets water, we actually want the sump pump to run for more than just a few seconds. And so I've programmed them so that if a signal does come from the floats and is observed by the ESP chip, it does put its signal coming off of D7 high, which then runs the pump, which you'll see a little red light on this relay. It runs it for like 20 seconds, which is a little bit long, but it's not horrible. But I've also got some home automation tied in that it will
ping my Amazon Echo device and say, that's not normal, you need to look into it. So let's start with the lower of the two pumps. So that lifted up, I put it back down. I don't know if you can hear it, but that was my Amazon Echo saying something requires immediate attention. We've also got a longer run on the relay, and I'm not touching the switch. So that'll turn off. It's probably a little bit long. I need to trim that down a little bit because we don't want that sump pump to run when it's dry. The other float is the last chance to fix this thing. And it also has in its array here an alarm. And I think I demonstrated this earlier, but let me show you. If that top float goes high, that alarm also fires. And then I get that ping from Amazon. That is all done in OpenHab. That's the software that I'm using to control the Amazon connection, and it pings my phone and stuff like that. So before I take this chip out, I'm going to cut the power, and I've just got a really simple power supply on my desk here. It's this. It turns 12 volts coming out of a transformer into DC 3 volts, and that's convenient for me. So, and it can be adjusted up. Those are really handy to have. So let's go ahead and pick this ESP chip out of here. You have to remember. Oh yeah, I also built in some automation that if this is removed from power, it will scream that there's problems going on. So I can actually put it into a USB to provide it with power to mute that alert. So, okay, we'll just leave that off to the side. Now, let me plug this back in. And what you're going to observe is this thing is going to go crazy because it can't decide if it should be high or low. So we're powering up. See, just my finger approaching this area. Can you hear that? It's not a solid on. Oh, and now it's just stuck on. Still high, jumping all over the place again. This behavior can be fixed with another pull down resistor, which I thought while I was cleaning up, I allowed to stay on the counter. Where did I put it? Where did it go? It's just a simple resistor between ground and that line. In fact, anything could pull that down. Oh, darn it. Where did I put that little resistor? It was very convenient. It's not something I'm planning on documenting for use because I don't plan on this thing being disconnected for long periods of times. So let's just put a jumper between that and ground. And now we have forced that leg low. That's the only thing about this chip that doesn't make it perfect. The fact that it's dependent on this if you take the chip off. And I might just throw a permanent resistor here, really, really, really high, something so very little, very little voltage is leaked, but I just need something to make it rock solid. So I'll consult with Claude. Oh yeah, that's the other alert that I've got going. So because this is connected to a power source, but it's not connected to any of the switches, it's throwing some of the things high and low. And so another rule says that if it's turned on for a long time, you need to alert the alert stuff. So lots and lots and lots of protections. I'll bet you can guess why. I've had some problems. I think I'm in a problem state right now. And so I'm motivated to get this project going. So there, we kick that back on. All of my alerts should clear out. And yeah, back to normal. So, okay, let me break this board off of this board so we'll have an empty board to start with. And I'm sorry I got ahead of myself. I mounted a few things to it. Just because, once you're in the mood, you're doing stuff. So let's take it off. And let me explain just a little tiny bit more about my setup here. I think there's things of value.
Oh, by the way, last thing, I also mounted a port right here for voltage because I have a logic screwdriver that I can use, or a logic pin locator that I can use to trace where things go awry. So let's move this whole thing out of the way, try to keep the floats from turning themselves on, and that will free us up to start working on this other chip. Oops, I need to break the chip off first. There we go. All right, so here we are. Let me explain this setup. I've got a cast iron frying pan on my table, on my chair here, my bench. And the reason is that I really enjoy using these spare hands, little guys, but they're very light. They're not really heavy, and they're great for holding some things. But if you ever have wire hanging off your table, they'll get pulled off. And so when I was tearing apart hard drives a while ago, I found a bunch of these really strong flat magnets in them. These won't be in your SSD hard drives. They'll be in spinning disk hard drives, RAID and stuff like that. Not RAID. IDE drives is what you'll find them in, or SCSI drives. And I find that if that clamps on there really well, it's spinning a little bit. I guess it's on a high spot. Let's see if we can turn the magnet so that it's grasping a larger size of that, and then put it down. It'll do, yeah, there we go, a little more solid. This way, I can tighten these and they'll actually hold stuff for me. So, little trick of the trade. It's how I hold my stuff while I'm working on it. And then here's the other thing that might be different that I do. I like to use really flexible silicone coated wire. And I have a procedure that I do that makes it so these actually work. Let me turn on my soldering iron. Let me get some of my test leads here out of the way. It's always nice to have a bench voltometer nearby so that you can test things. It comes with some leads. So while my soldering iron is heating up, let me put a few things away. I kept a lot of these tools out because I need them. I don't need those screws. I'll just put them up there in the drip tray. I like to use hemostats inside the house. I know I use them out in my shop a lot, but they're really handy for this kind of stuff as well. And especially tweezers. Tweezers help me a ton when I'm grabbing the hot wire. But here's the procedure I follow. I like to start by making a long lead. I twist it as much as I can, especially the end. In fact, I'll even go a little bit overboard and twist the end darn well. I take my solder, which I have just spooled up and then placed inside a little medical container, and then I poke a really small hole in the top. I've seen these with much larger holes in the top. They're kind of long. The solder flops all over the place. No, that solder is bound to that lid. You have to pull it pretty tight. And we'll try to get that into an easy position for you to see. Dab the solder in the stuff for a second. Bring these together. And I just put a dab of solder on the tip. Just enough to keep it from, when I try to put it into the hole, little wires splining off. When you're dealing with anything electrical and you have wires that come out of where they're supposed to be, they short stuff out, and it can be bad. So a little dab of solder. You do need to be careful that you're not making clumps. So if you're going to drag, you got to drag away, forward. And then I can put this, I'm pretty sure which place I want it. Let's just have it jump from here. So that's the negative, the ground. And on this other board, which I'm going to use now as my example, this one hops right up here to the ground of that IC. So I kind of drag the wire to where it wants to go, and then I trim it or cut it with my trusty shears, and then I repeat. And in this case, I know it's best to measure
twice and cut once, but that's funny. I don't think that's true. In a second, I'm going to stop this demonstration I'm doing with you. I'm going to switch to a high-speed camera, and we're going to do those time lapses again. I'm going to put on my glasses because I can't see very well. And then use these tweezers. And then I can decide how high I want it off the circuit board by trimming some of the silicone. That's not too bad. Let's take just a tiny bit off. So just a little tiny bit. And yes, I have to fine tune. This takes a while. It's actually kind of painful on the lower back, but the result is functional. It may not be the most beautiful, but it's functional. It does take time though. So we will finish this solder by turning the board over, and notice that it has kind of popped up off the board there. That's not a problem. We'll take care of that on the other side. So I grab some tweezers, give it a little yank. Okay, so that's about as good as it'll go. It'll stay right there. I'm going to go ahead and put these glasses on now. And now I can put a blob of solder on it. This is the first solder blob. And remember, this is stranded, so it's all loose, and we're going to make this a solid wire when we do this. So, decent sized blob of solder. And now, I grab the tweezers, I heat the blob again, and I pull up. Drag over, heat the other, and I try my best to get down below. And you know, that solder joint right there is really dry. So we're going to put a little more solder on it. Okay, now that it's going to flow solder for us, grab, push down, let it sit for a second, warm up, and drag up, and then we'll trim that off. So same thing over here. Get in nice and tight, put a blob. Lift a little tiny bit, extend over, and then heat the other solder joint. And this one feels dry again, so we'll put a little more solder on it. There, that should be a nice, good clean solder. Let the solder flow through that whole wire, make it nice and firm the whole way through. And then the last step is to come in and trim, and I try not to grab them with my hands. And sometimes you can just come right from above and nip. And nip. There. That is basically what I'm going to be doing for the next few hours. Right there, nice clean, just close to the soldered thing. I'm only making 2 of this board, so it's probably not going to be worth it for me to buy a pre-drilled and circuited underneath with all the connections. It would be nice, but I'm not that person yet. This is a hobby, and I don't have the need for all that. So I'm going to wire this up the same way I did the other one, and then I'll show you guys how I prep an ESP device to work with the rest of my network.
solder that I made is me trying to avoid where I can jumping on the bottom of the board. I really like it when your wire can go through a hole, be soldered, and then dragged to the contact. But over here I didn't leave enough room for a second jumper of the ground, so this ground wire and that ground wire needed to touch, and I did that by an under the circuit jumper. I hate doing that, but it's necessary in this case. Could have gone from just there to there with a bare wire. Probably would have been a lot easier, but you just got to be careful. Don't put this ground to that hot, or else you'll short it out. And before we turn this guy on and provide power, we'll test for resistance across the two power leads to make sure that we're not shorted anywhere. But that is pretty much the wiring from the two floats to the board. I still need both of these to travel over here, and one of them needs to come down and power this jumper here for the siren. So we keep working. now we have something a little more challenging than normal. I'm going to try to put these two pins on the board. They'll feed power to my diagnostic tools and things. And what I like to do is to stick an earplug on the end. Okay, so I can see the pins there. And in theory, if I place this on the flat surface here, that earplug will press on the ground and I can use my hand to do this. But because this is the way it is, I can actually hold it with my mouth. Once one pin is in and done, then I can check the alignment. That's a little crooked. So we'll just kind of put our finger on the pin that isn't going to get really hot. And just kind of straighten her up a little bit. There. Perfect. Just thought I would share that way.
All right, we've soldered the entire thing. All the wires are in place. I have these in this and this removed, so we don't need those yet. What we're going to do, thankfully my desk voltmeter has these nice leads on it that I can attach that allow me to just go right onto pins. So we're going to do that. I'm going to set that. And what we're going to do is we're going to use the contact setting of the, like a little fluke over here. And we're just, if it beeps, then we'll know that we've got the positive and the negative touching each other. And there's no beeping happening, so that's good. So the next thing to do is we need to supply some power to this guy. And let's see, my power guy. So I need to, I'm going to turn back on the soldering iron. We got to put together just some wire so that we can plug in here and here. I want to leave these available because we're going to connect our probe to that next. So give me a second to build a lead for that. All right, I've changed the voltmeter to test for volts, and we are now ready to plug it in. Okay, good. So immediately on the voltmeter, we're registering 3.385 volts. So that's good. That means that the solder job from this connector all the way to these is good. At this point, if we want, we can, let's see, disconnect the red side, the hot side, and just kind of go around and make sure we've got power where we want it. So yes, I can't check those. We can check this pin on this IC. Very good. So, okay, we know we've got
voltage going. Let's switch over to the logic probe. Now this is a nifty tool. It plugs into the plus and minus. So let's get that plugged in. And that turns it on, basically. And it tells me lows and highs. So it's great. I can see the high, but now I can also see the low. So that's cool, right? And now I can check that we've got ground there, ground there, ground there. And let's see, both of those sides should be ground. I can check this pin here. Good, I've got grounds where I want them. There should also be, I think this one should be a ground, this pin. Oh, that wouldn't be because we don't have the chip in. Okay, let's flip it over real quick. Other places we should have ground. We should have ground at the transistor. That's ground. High on this side, on the opposite side, which is interesting because, oh no, we are sending voltage through it. All right, we should have ground and high. Very good. Similar. And then these are the digital inputs. So I'd say we got our wiring done correctly. That's good. Let's continue our wiring by syncing this guy right here to ground. And how was I doing that last time? I believe what I had to do is I had to connect that ground there and that probe there, or that. So that input to the chip that's going to go over here will now be pulled low, which is what we want. So the next chip we want to install is our OR gate. This is basically the switch. This is what tells the entire circuit if that relay should be on or off, and it makes all those decisions. So, and it's really simple decisions. It's either is something coming in on or is something coming in off. And if either one of them is on, it just is, the output is on. So I'm going to put my glasses on. I do have to bend these legs in just a little bit. I've noticed that the holder that I bought wants these to be in just a tad, which is probably not good for you to be putting your hands all over them. And this is why the wires are long around these, is so that I can do that. Move them out of the way. The orientation is up on this one. I want be more flexible. Oh, and we are sending power. Maybe I'll disconnect the power while I do this, although it's probably too late. All right. Yeah, that looks just a little bit off center and goofy, but it's going. I need all the pins to work. Okay, seated all the way in. Oh, look at that. One of our signal wires, we left a whole bunch of wire up top because I didn't pull on it hard enough. That's ugly. I don't like that. Can you guys see that? Did I do that anywhere else? Let's see. We don't have power going to it. It's the second one right there. 1, 2. You know what? Let's just fix it real quick. I'm not going to be doing this again for a long time, so we may as well look at night, make it look nice. Let's see. I think is it that one? Did I forget already? I'm pretty sure it's this one. So we need to loosen it. Why is there a little wire stuck? Ooh, this is going to be ugly. Okay, we got it. Okay, so that was lucky. All the way up, and then we kind of dehydrated that joint. We took a lot of the solder away from it. Let's give it a little touch of solder. There we go. Well hydrated. I don't know if that's a technical term. It gels with me though. Okay, and then we just nip it right off. We ended up really close to the board, so these nippers couldn't quite get to it. Okay. Sorry for that delay. I think everywhere else is just darn close enough. So, okay, let's restore power. And now with our logic probe, we should be able to measure a whole bunch of no's. So that should be no. Oh, that's high. Why is orange high? Oh, I know why. Because this expects these to be on and it reverses them. So perfect. This is a great test. Remembering, okay, so coming in is low, going out is high. Coming in is low, going out is high. Awesome. So we need to, if we want to continue testing, we need to short those out. Oh, you know what we should do? We should make sure that all the way over here at the pump, we got high, and we do. Good. So that means at least these two inputs would make it turn on. So to short those out, let's make this easy as possible. Let's get a couple of these, or I have some just random wire sitting over here. Let's do what we're effectively doing with the floats. Let's bind this wire together. Sorry this is so slow, but you guys are just kind of experiencing it as it happens, and that's how it is. And hope I hope those shots are kind of cool of the solder smoke rising. I don't know. I'm not an artiste. Okay, we'll nip that, and then both of these ends. We need to solder them all the way down to the wire. Otherwise, they won't be firm. And we won't be able to push them into these connectors. By the way, another tidbit, I don't love these connectors. They require manual opening and closing. So like after I loosen the screw, I have to stick something into them to make room for the wire. And some of the more expensive ones, like the ones on this relay, where did it go? There it is. I really like them because as you loosen the screw, it actually, those two metal plates separate. You stick your wire in, and then as you tighten the screw, the bottom plate comes up and pinches. That's really cool. Makes room. Whereas these ones, what I'm dealing with is this is a piece of like sheet metal, and as I loosen the screws, that's fine. The thing that's pressing the sheet metal down moves, but there's a memory to it, and it's difficult to get this. There's actually a lot of connectors I could have used, but because the wires I'll be dealing with are somewhat large, I wanted to go with these ones. But look at that. It's not easy to insert those, but we got it. And then I'll use these to do the other ones. That's why you saw me stick this in there, and I stick it in there and just turn it side to side, kind of open it up a little bit. They do grab well, so once it's in there, it stays in, which is good. Okay. We no longer have anything pulling this high over here, so we should now measure low. Good, it's low. So what happens if we fiddle with the brown one? So right now the brown one is low. If we take this out, now it doesn't know what to do. And this is, do you hear it? Going kind of crazy. So if I pull that high by shorting it with 3 volt, Now we'll have steady high. And this is the reason that this whole circuit went down to 3 volts. I was going to do all of this at like 5 volts. And Claude said, you know what, you really ought to consider doing it at 3 volts, the whole thing, so that you don't have to worry about voltages coming and going. So let's see. If the brown is high and the green is low, the output is yellow, which is high. This yellow one comes up here, it's high. The orange one is low, but the output, which is the long yellow, is high. And there we go. Okay, let me reset this again by grounding it. And the other ones are just about as easy to test. Let's see, what's going to be the easiest way to test these? I guess, let's see if this resistor can do it. Oh, I just threw the resistor on the floor. Dang it. All right, so we want to resistor across these. Oh wait, let's test first. We should have low as our output. Low. By the way, I have no idea what size this resistor is. High. Low. High. Okay, that passes all of the bench tests. The next thing we need to do is flash the code onto the little chip, and maybe I'll make that a different video. That might actually be something that is not related to the soldering of one of these devices. And then I got to install it, and we might make that a different video too. I don't know. Should we make a long video? I don't know if people like longer or shorter videos. I don't know. So let me finish, and I'll try to record the flashing process, but it's hard to record the computer screen while you're talking, and it's just weird. So anyway, we're done with the circuit board. It passes all of our circuit board tests. Well, I hate to leave you all in suspense, but I think this video is long enough as it is. I do eventually fix the problem. I'll show you in the next video. But let's not make this video longer than it absolutely has to be. So go outside and, I don't know, have a sip of lemonade or something like that. And we'll do part 2 in a different video. Thank you for watching. As always, appreciate everybody who does. Have a good day.